let me introduce myself. My name is Rod Hirsch. I'm a former federal worker. I used to work for the U.S. Department of Commerce, International Trade Administration, U.S. and Foreign Commercial Service. That was a mouthful. It's part of the Foreign Service. And when you talk to me about dual tech, what that means to me in my former government life was products and services that could be used in either a military, DoD, government application, or a commercial private sector application. That's the way my world was divided. And so for some of you, you may be familiar with ITAR, the International Trade in Arms Regulations. That was my bread and butter, the Bureau of Industry and Security. These are the government agencies that regulate the export of sensitive dual-use technologies. So in my job capacity, I'm not a veteran. I am a Peace Corps volunteer, not a Marine Corps person. So that's my background, not any military background. But my panel, we have some veterans on our panel here. And so what I'd like to do is I've had a chance to actually work with Alex and Neha in my prior federal government capacity. And I'd like them to give a brief overview of their background. I mean, they're multifaceted, talented, this is a super cool panel. I'm going to start with you, Alex, since we already talked about your cumbia or what have you.
I am the founder of a company called Circuit Launch. We started about 9 years ago as a co-working space / a maker space. We took a empty warehouse in Oakland, 35,000 square feet, was empty for over 10 years. And then we evolved to what we call today a co-factory, which is a shared space for prototyping and for you to build your first few thousand pieces. We grew to 2 campuses. We have one in Oakland, another one in Mountain View. We have over 120 companies within our ecosystem. Collective, they have raised over $400 million while residents of Circuit Launch, and they have provided thousands of jobs to the community. Has been an amazing opportunity for me to see many companies right now started with one little desk and grow to 100 people and over, and I've seen this many times now.
Hi, well, good afternoon, everyone. My name is Neha Groves. I'm the VP for Tech and Innovation at Ocean Power Technologies. We focus on marine technology. We have mobile and stationary autonomous assets that we provide to both the commercial and defense sectors. I've been with the company for about 4 years. Prior to that, I was in oil and gas for over 14 years. So I've been in marine technology pretty much all my life. And dual-use technology is right at the heart of that. So very excited to be a part of this panel.
Oh, there it is. All right, Sandy, you go.
Hi, I'm Sandy Therrien. I'm prior service Air Force. I was an avionics tech and flight line mechanic on the mighty C-5 Galaxy. Yes, that was a while ago. I've been in aerospace and defense for more than 30 years, and I'm the founder of Blue Moon Space Operations. So we are building a sustainable orbital infrastructure, starting with orbital debris capture and repurposing. So we're not going to bring it back to Earth, we're going to recycle it right there in orbit.
All right. With this prestigious panel, I'm going to start off with a big picture question to all of them. What are the most promising examples today of human and autonomous systems working together to effectively, whether in defense, surveillance, domain awareness, etc., public safety, manufacturing, agriculture, or logistics? If you could draw an example from any of that broad spectrum.
I think the flock system in San Francisco is working well. The flock cameras with the drones. If you haven't seen it, they have a whole array of cameras throughout the city that keeps manage everything that's going on. And when there's suspicious activities, they send a drone up. I think that's an interesting aspect of automation. I can see future they sending all this stuff out, then they just drones. They can send humanoids out. And it's a way for you to verify without having to pursue, with at least not having to pursue inside the city and to kill other people. That's a good example.
This is prevalent across various industries and sectors right now, right? Like if we're looking at any kind of autonomy, it's providing the most value where it's extending human reach and capability. In the defense sector, for example, we're looking at greater surveillance capabilities, information gathering, right? Putting drones in places where it's too dangerous to put people out there. So, that's definitely one of the more critical applications right now. In manufacturing, of course, with automation, we're looking at robots doing repetitive tasks or precision-intensive tasks. In the marine environment, for example, with OBT, the most important or the most valuable aspect for us in this partnership with autonomous systems is cost-effective force multipliers that they're proving to be. So we can put these systems in areas that are otherwise constrained or contested in some way, shape, or form, difficult to get to or otherwise restricted, right? Like marine protected areas. Public safety, first responders being able to get immediate situations before they go out into the dangerous environment. I mean, I'll throw in a personal note here, but I don't know how many of you are aware, but there's a massive fire raging in the middle of Utah right now. The smoke from which is extending all the way out to Kansas. Like it's insane. That fire blew to 60,000 acres in 36 hours and is actively burning through infrastructure and homes and really impacting lives. My husband is there as we speak fighting this fire, and so how much of this could be augmented with autonomous technology? How many drones and other systems can we put out there in these dangerous situations to not only give us a common operating picture of what's going on, but also start the response and actually, create the systems to mitigate damage. So yeah, for sure. I think the bottom line is it comes down to how can we extend human reach, and that's the most important application.
That's a good segue for you, Sandy, on extending the human reach into space.
Well, that's a fact. So flying satellites is boring. By having an autonomous system that's mostly autonomous, we can have a human in the loop to monitor in case something doesn't go quite right. But for the most part, doing boring jobs like, doing micro adjustments to a system to keep a satellite flying is a very important job that can be autonomously done. So, but with a human in the loop for safety.
Okay. All right. I have a next question here. How should companies think about the balance between automation and human decision making in high stakes environments in terms of accountability, reliability, and the avoidance of harm or loss? This was kind of a controversial discussion we had prior to this conference. Some of you may have heard that, in the military, they're blaming things on AI. And so where does the robot end, the human begin, vice versa, and who takes the responsibility of what happens?
I believe that any human liability that's going on right now, that's all temporary. I don't think there's any high stakes positions where robots and AI will not be able to do the same job, probably better. I'm just not in a camp of we're augmenting humans here, and any augmentation is just temporary. At least that's how I see it. So as of right now, I think situations where someone can get killed, it is the only part where we probably should have oversight for now. Any place where someone can get hurt seriously, that is the only areas, but all of this is temporary.
Yeah.
Well, I have some.
You have some views on this. Share them.
Some views on this. I think it's important to remember that AI at the end of the day is ultimately just a tool, right? And any tool is as good as the operator. Delegating a task to AI does not absolve the operator from accountability. So AI should especially in high stakes environment, in critical situations, it should enhance the operator's ability to make decisions quickly and more effectively with more information. It should not obscure responsibility. So we need to ensure that, there is accountability structures in place so that, ultimately this is a tool that you are using. You are accountable for the outcomes and the consequences of that tool.
Do you believe AI always gonna be a tool and never is gonna have autonomy?
I think to a great extent, for sure, right? Like it should never be human out of the loop. It should be human on the loop with full accountability, because AI there's only so much you can program into any kind of algorithm. You're always going to find those edge cases where it's not performing the way you wanted it to, or it did not make the decision you wanted it to. You need the human available to make that kind of critical distinction, to be able to identify the anomalies, to make the insightful, interpretations from the data that's coming through.
No, but you don't think that can change in the future?
I think it'll definitely get refined. I don't think it'll completely go away. It's personal.
Sandy?
Well, I agree that it probably won't fully go away, but rule number one of capturing space debris is don't make more space debris, right? That's kind of a no-brainer. But we want to be able to get to the point where we can trust our robotic spacecraft to do this operation by incorporating some air-gapped AI into our system, because it can take a couple of seconds for a command from our mission control center on Earth to get to those spacecraft. So they're going to need to be able to make an intelligent decision on whether it's safe to connect with that piece of debris or not. So there is going to have to be a certain level of autonomy that we're going to have to build into our spacecraft in order to do this. However, we always need to monitor, right? So if something doesn't look correct, we need to make sure that we can cancel that command and back off the mission and reassess.
Okay, great. Thank you so much. I have another question for you guys. Defense organizations are investing heavily in autonomous systems. What lessons from military applications can be transferred to the private sector, commercial industry, and vice versa?
Yeah, but we use no drones, use humans. So drones and robots is something very recent. And then other than Ukraine, there's no really other force. We actually use this in a way that is very visible. U.S. used drones for a long time, but not in a scale that we've seen in the Ukraine-Russian war. So I don't have really an insight.
How do you see that affecting the private sector? That all that drone use, whether it's terrestrial, marine, aerial, how's that going to affect us in the private sector world?
This is actually maybe one of the areas where the applications on the private sector influence more the Army than the other way around, where I'm seeing a way more innovation from this side and being applied to the military eventually than the other way. Again, it might be stuff in the military that I don't have access to it that might be that help us at some point, but I'm not seeing that influence as we saw with the internet, with all this stuff before coming from that side. And again, don't have any insight in it, so I'm not sure.
Okay, Neha?
I think this has always been a two-way street, right? The flow of innovation has always gone back and forth between defense and commercial markets and sectors. I think, from the defense sector, we learn a lot about resilience, systems that can operate at scale, be sustainable, have the resilience to work in environments that are either contested or have degraded comms or both, or just have incomplete information, or be able to respond to rapidly changing conditions. Whereas with commercial applications, we learn the economies of scale. We learn about how do we, actually make this economically sustainable and be able to deploy at large. So I think that sort of that dual technology aspect of it comes in. All the companies that are in the sector right now should be able to take advantage of both the strengths of, resilience that is required for the defense sector and the scalability and the economic aspect of the commercial.
Sandy?
I'm going to talk about the weather. So the Space Force discovered that the data you gather from weather satellites that track changes over time for places on Earth can also monitor battle spaces and potential operations areas. So, yeah, put a sensor on spacecraft that are operating up there anyway and gather data over time about a space that you might be interested in the future. So that's an example of commercial going to military applications.
Now, I'm not a panelist, I'm the moderator, but I'll make a couple of comments on this from a former federal government standpoint, and it's going to be on the money side of things. In one moment in time, private sector capital, angel investors, banks might be a funding source, revenue stream. Then all of a sudden, they may not be. And then you may have to shift your attention to government revenue streams, depending on the operating environment. So these are, you as companies, founders, should look at this equation as two sides of the same coin, depending on the situation of the day. The military or government could be your revenue source when private sector revenue is not coming your way. I'll leave it at that. This is a follow-up question. How is your business addressing the cost, human capital, and infrastructure needed to sell to the government? U.S. manufacturing requirements, U.S. citizen requirements, cybersecurity requirements, ITAR, etc. Can you, Alex?
Well, there's a lot of small companies that come out of space, but I don't think we're kind of like catering for that specifically need. It's hard to deal with the government. It's hard to sell to the government. It's hard to actually deal with all the requirements that the government applies. And startups, for the most part, should not be selling to the government, for the most part. And by startups, I mean people with 1 to 4 people, because you're really worried about your next source of revenue. And then, a few weeks in a negotiation with the army, it can kill your company. So avoid things that are very big and very complex, and the government's one of them, except when you're already getting money from the government to fund your company, which is the case of a lot of DoD fund a lot of the companies, a lot of the grants, where your project's straight to the government. So you're almost working as a part-time employee for the government while you build your grant. In that case, sure. But most people who went to that route, they're only doing that because it's so demanding. And only after they finish those relationships is that they're going to go sell aside from this. So my personal recommendation as a startup, especially in the hardware space, do not deal with the government if you can.
Duly noted. Neha.
This is actually one of the most difficult challenges for any technology company out there, right? And I think this has been discussed pretty extensively in the previous panels as well. Only half the problem, right? You also have to put in the investment and the people capital into setting up the infrastructure around compliance, around cybersecurity, workforce development, setting up your manufacturing for with the idea of scaling that on short order. Supply chain resilience, one's a doozy in this day and age. But this is kind of what we've been doing at OP. Beginning is setting up all of these processes and all of these CMMC certification, for example, getting your compliance with export control, making sure that we have the workforce and the processes in place to be able to cater to both government and commercial. I think that's typically a big problem, and that needs to be considered for any company that this is a pretty significant investment and time-consuming process.
But you're diversifying your revenue streams.
Absolutely, yeah. I mean, once you need to get your leg in the door, but when you get that big break, right, that's what you're really pushing for. That solves all your problems, But then you get that massive contract from. And it all makes sense, but there's a lot of work that goes into making sure you have the inroads with the contractual, offices and the right people. And again, this has been talked about in the previous panel, so I won't expand on that, but it's sort of a very important consideration.
Sandy?
Yeah, absolutely, Neha. So when I stand up a laboratory to build my prototype spacecraft to capture space junk, that's an engineering problem. We can do that. But when the government wants to get involved and put something special on that spacecraft, that means I'm probably going to need a separate lab. That's an expense. I'm probably going to need to hire some folks who are U.S. citizens or authorized to work here because they're going to be working on things that are controlled. I might have to stand up a skiff, depending on the level of security needed for those sensors and things that are going on our spacecraft. There's all these.
You may have to explain what a skiff is for those non-governmental folks out there.
So it's basically a room that's very quiet, so you can have very sensitive conversations that won't be overheard or intercepted by folks who have interests contrary to the United States government or Department of War. So you don't want people to be able to overhear or pick up your conversations. So it's a special room for that. So in addition, as a startup, to having my lab that does the hopey, changey, wonderful cleanup things, if we're going to install sensors on the spacecraft that are sensitive, I need to have a separate lab, people devoted only to that activity, and some protocols and other costs that are associated with all of that. So if you're going to start up a business and you want to work with the government, you got to consider that into your planning, because they're not necessarily going to give you funding right off the bat to stand all that stuff up. You might have to do that yourself.
Yeah, she brought up a good point that I think I should enhance, which is the dealing with the securities. A lot of the founders are immigrants, so therefore they by default cannot work at the government. So take that into consideration. One more reason not to work with the government.
All right. Now, we've all heard about how robots and AI are going to take our jobs, right? But I'm going to ask our panelists kind of the flip side of that. How do autonomous systems help address workforce shortages, operational risks, and mission challenges?
By the way, robots will take our jobs.
We're supposed to make everybody feel comfortable in the audience.
Just we should stop with this nonsense that we're just helping people to do tasks that they don't want to do. I've seen the dollar develop in the last 36 months. There's no way we're going to be able to compete with this. There's absolutely zero chance, in my opinion. So the whole talk about, how we're going to help humans is just a talk from the companies that want to raise money. They cannot say any other thing. But I think we should be honest about this, because the impact of this is really serious. And I just don't even know what the question is anymore. The rest of it.
All right, Neha, take a stab at it.
I mean, I'd like to take a more rosy look at that, right? I think that historically we've seen technology hasn't necessarily eliminated jobs as much as it has changed it, right? Like, for example, autopilot on aircrafts hasn't taken the pilots out of the picture. It's just enhanced their ability to do their job more effectively. So I think that is sort of the attitude and the perspective that we should be taking towards this. Like right now in our sector, we're very actively looking for autonomous system operators. We're looking for robotics engineers and technicians. We're looking for software engineers who are developing the interface between human and machine. AI and perception engineers who are developing the AI algorithms or the autonomy capabilities on any system, right? So it's more about generating that workforce and the skill set to manage and run fleets of autonomous systems rather than a single machine. I think that's how we are evolving, and that's not necessarily going to take jobs away as much as it's going to just refine them.
said that. Sorry, I have to one point to make here because this is important. You said that a plane still need a pilot, even though that we have autopilots. Do you believe that a autonomous system can drive a plane better than a human?
I mean, probably.
Just on a tech.
In terms of,
You believe it can drive better than autonomous car?
I mean, if you're looking at, just the airplane system, I don't think you can take the accountability out of the situation, right? That's the
But
bigger
that's not the
part of it.
question. The question is, do you believe that a human can drive a plane better than autonomous system? Or let's look at the car. Do you think it can drive better than the Waymo?
I mean, I think so.
You really?
Yeah. I'm still not convinced, right? Like I don't think that there is a situation right now, until I am proven otherwise, that an autonomous system or AI can fully replace a human being and not have the consequences that we're also afraid of having, right? I mean, let's look at Waymo right now, right here in the city, right? Any single accident. I mean, I'm not dissing that technology at all. They've come a long way. They're doing a great job, and I've ridden Waymos myself a lot, and they're making the decision making that's happening on the edge is pretty intense. It's incredible. But at the same time, they get into situations, they get into accidents, they create problems, and there has to be somebody, there has to be a human on the loop to manage that accountability.
Sandy?
Hi. I'm going to steer us in a slightly different direction. How many of you have worked the overnight shift, sometimes called graveyard shift? Yeah, that's fun. And like I said earlier, flying satellites is boring, because you just kind of monitor. So what I'm looking at is, by incorporating this type of automation into my systems and my processes, instead of having 3 people who are bleary-eyed at 2:30 in the morning drinking coffee mixed with hot chocolate to stay awake, that's called crew chief coffee, by the way, I'm going to have 1 person, because they can autonomously make those small adjustments themselves, the spacecraft on orbit, in order to maintain the desired altitude that I want them at. And so the mission manager, who prefers to plan next cool missions for capturing something, only has to kind of be 1 person instead of 3 on that overnight shift. So I can reduce my number of personnel on an overnight shift by 2/3 simply by having that sort of automation and agentic AI aspect built into my spacecraft. Still need someone to monitor in case something goes wrong, but I have fewer staff, and I have staff that's more wide awake.
Yeah, so that kind of goes back to what I was saying in terms of a single operator managing a fleet of systems instead of having multiple people potentially in, if not unfriendly, potentially dangerous situations as well, right?
But I'm going to say one more thing. Once upon a time, there was an autonomous aircraft that was a helicopter, and its name was Fire Scout. And this is something that the United States Marine Corps was developing. And one of the Fire Scout's jobs was to land on a littoral ship and set down on a target. So it's kind of this amphibious ship cruising along at quite a few knots in the wind. And the automatic system on that aircraft did a much better and more solid job of landing on that moving ship than a human ever could. So there are situations where a computer or agentic AI is better than a person. And we just need to be able to embrace that and let it do its job if it can do it safer and more effectively than we can.
Cool, calm, collected robot.
No feelings.
I'd crap my pants if I were trying to do that.
That's why I don't fly helicopters. I like things that glide.
Which situation today where when they're observing that a human actually needs to get into the loop on your situation for the satellites? Like, where does the system say we need a human to look at this?
Where does...
While the situations that you describe right now, where you have a lot of autonomous systems monitoring whatever the space is of the satellites, when does a human needs to get into the loop? When they say we need a human here to look at this?
Right. So if one of our reaction control valves malfunctions, so like you're cruising around in space, you have this canister of compressed air, and if you get a little off track, you're supposed to fire that so it'll adjust it back on course. Well, if that malfunctions, now I have a spinning satellite. And if the system doesn't automatically right itself, I'm going to need a human to interfere and decide what to do about that now spinning spacecraft that could become a problem. Can it be righted? Can it be fixed? Or do I have to put it in the recycle bin? You know, so we need a person to make that decision. The robot can't make that decision itself.
Any commentary there, Alex?
No, you're waiting for me to say something.
I'm waiting.
No, actually, I'm curious. I don't know how it works. I'm assuming that eventually that job by an autonomous system, by a robot. I'm assuming so. There's when you do an agentic systems, there's like the human in loop aspect of it. But every time when you see like a human in loop, you always think, how long is this human really needs to be on this loop? And as we move more into understanding how to manage things that we don't need to understand how they operate, it is the human to let it go of the idea that we can do better, then less of the human in loop you need.
As you can tell, Alex is very pro-robot and con-human.
I'm not necessarily pro-robot against human. It's just I think that the narrative that we're just saying, well, you know, humans always going to be needed, it's not very helpful. It's just not helpful. We're talking the wrong conversation here. It's much better saying, I don't want to take much time, but there's a research that came out recently that I think exemplifies what I'm saying. But last year they did this research where they had 3 groups of people to diagnose medical cases. And then there was one group just with humans, just doctors, one group with the humans using AI, and one group just with AI. So the humans only, the doctors, they got it right about 74%. So every 100 cases, they made 26 mistakes, right? So the AI obviously did better on that situation, but it's 90%. Every 100 cases, they got it right 90 times, so only 10 mistakes. That sounds good. So I'm thinking like, man, the humans with AI are gonna do really good at this because they have the knowledge, now they have the tool, and they're gonna do really good. The group in the middle, which I used to call the superhumans, they did 76%. Only 2% better than the humans only did. Anybody here has an idea why? One of the hypotheses because we believe AI is wrong. And every time when you bet against AI, most of the times we're going to be wrong. So this is an example where I think the narrative of making us believe that we're somehow going to be useful in this scenario is just not helpful.
All right. I have a question relating to fallible humans. What skills should today's workforce develop to remain valuable in an increasing AI-enabled and robotic future?
So here's one area which I think is important. Humans are still very ambitious and capitalist in sense, so they wanted to get stuff, value, and money. And they were very good at emotionally manipulating other people. Now we're going to be very good and do it with robots, because robots don't need to feel anything. Robots need to make us believe that they feel something, and they're going to be really good at that. But we're really good into understanding another human and manipulating the other human into doing something. And then the recognition of what the human wants, and because what someone wants and how we buy it, it's not necessarily just a very straightforward thing. It's a group of emotions that we got really good at reading. So the entrepreneur that can focus on how to identify patterns of emotions where they can convince that group of people to buy something from him, it's very valuable.
Okay.
I totally forgot the question. And
Workforce development is the basic gist.
the skill set, right? Yeah. So I think first and foremost, AI literacy is critical, obviously, in the age. Secondly, I'd say holistic systems thinking, right? So the most valuable expertise that I am looking for currently is the integration or the intersection between software, hardware, AI, and manufacturing, like pulling all of that together, that is going to be critical. And then thirdly, I'd probably say judgment, right? So critical thinking, the ability to troubleshoot and take insightful information out of what you're looking at, the data that you're looking at, and be able to support and sustain these systems long term.
Any suggestions for the workforce out there?
Sure, yeah, absolutely. If you're a more mechanically inclined person, I would suggest human-machine interface as being a very powerful and good thing to get into. If you're more of a geek and a software type person, definitely your software engineering degree, but supplement it with agentic AI and AI certificates is probably going to be the best thing that'll help you in the next 5 to 10 years.
All right, thanks, Andy. I'm going to get kind of big picture as we end this panel. What breakthrough in robotics, human augmentation, wearable technology, AI, autonomous systems, etc., do you believe will have the greatest impact over the next decade? Big picture.
Capacity of processing locally, because there's a lot of things we can still not do because we cannot process this thing locally on the machine fast enough. And then in the situations where we can process fast enough, we cannot keep it cool. So that's huge. And also battery. Those two things alone will pretty much frog-leap us from this stage where we're now to the next one.
So battery tech, you're bullish on battery tech.
Battery, we need battery. At least smaller batteries. It's not even bigger capacity, it's smaller batteries that can produce more output.
What about grid-tied batteries? Grid-tied batteries.
To be seen. To be seen, yeah.
I agree with what Alex said for the first time. But yeah, I mean, definitely edge processing and battery technology is going to be huge. But I would go with a bigger picture in terms of collaborative autonomy, right? So systems that can work together in various mediums. We're looking at air, ground, marine, subsurface, even space, right? Systems that can create an ecosystem that talk to each that can share information, that can work on, combined goals, and that can create a common operating picture. I think that's going to be a very key advancement in our technology.
I think for the general everyday person, wearable tech, I think, is going to be the biggest impact in the next 5 years. If you have spectacles on that have an AI interface, I'd be able to look at you, sir, and if you have a tag on or something, I'm going to be able to see your entire resume right before my eyes and know your name before I ever shake your hand. So I think wearable tech, especially like in health industry and stuff like that, is going to be very important. And for the warfighter, we already have heads-up displays, but I think an augmentation with an air-gapped AI system will also really help folks like pilots and people who operate big machines to have that extra interface that gives them information about their battle space. So that's what I'm thinking is going to be impactful.
Okay. I'm actually surprised nobody mentioned exoskeletons, because I worked a lot with companies since this event is all about veterans. For wounded warriors, these exoskeletons can give them a new life in terms of their physical capabilities. And then also these exoskeletons, and you've seen them in, Aliens and what have you. That's a reality today in terms of mission, actually using exoskeletons to accomplish certain tasks.
They're very limited because the battery source of a lot of those things cannot be big enough. And then, the whole thing about augmenting the human, it's cyborgs, right? We're all cyborgs already because we outsource most of our technology to the phone. So if I remove the ability of half of you to choose your phone, and you cannot compete with the other half. So we are all cyborgs. So now augmenting that battery becomes a huge issue.
By your opinion, what is a bottleneck in modern autonomous robotics and autonomous systems?
Bottleneck with what specifically?
Like, for instance, all these robots, they are like drunk people. What will change? What is the bottleneck? How can we improve them?
Well, I'm glad you asked. So, right now, I'd say with autonomous systems, we're in the Wild West eras, right? So there's a lot of technology out there. There are a lot of startups out there. There's a lot of systems that can get deployed. But what we're lacking right now, and I know this is a very unpopular opinion, is a standard of operation or a regulatory framework that we can really measure our systems against, right? And I know there's going to be a lot of people unhappy with that stance, but the fact is, if you don't have performance metrics to judge a system against, then that's not going to, how are we going to figure out whether a system is good enough for a certain application? So I think, one of the, that's a huge bottleneck specifically with government contracts as well, and not just that, but also commercial aspect. If I'm thinking about right now putting a fleet of my autonomous surface vehicles out in the ocean, what is their data set that they're going to be working with? What are their rules of engagement? The core regs, I don't know if anyone's aware, but the regulatory requirement to have vessels in the water, that's open to interpretation even for manned vessels right now, right? It's not watertight, pun intended. So, how do you do that with autonomous vehicles? You can create infinite if-then loops in your algorithm to create these complex behavioral patterns, but you're always going to find those edge cases where it doesn't quite perform the way you want it to. So I think we need to have that system or that framework that these autonomous technology can fit into, and that we can understand how they're going to behave, because the large-scale implementation and adaptation of this technology is going to be limited without the trust from the public sector, and without the full the reliability of this technology.
I actually summarize this into 5 or 6 bottlenecks: processing power, battery, material engineering, which takes from material engineering to production takes about 10 years. Maybe 7 in China. Then you have data collection, which if we keep using language models right now, the interaction of humans, we don't have that data, so internet and simulation does not work very well. And the 5th one, believe it or not, it is we don't have humans working on this area. Actuators goes into material engineering. Actuators is a lot of material engineering problem. It's a mechanical engineering problem. And then there's a lot of people moving to those things in-house. But those is one of the things that eventually I think is going to be just a commodity. And then to her point, the standards in the humanoid side, for example, there's no standards to build this. I think it's a very, very bad idea for people to be importing humanoids for the military aspect of it. I think it's a very bad idea. I just don't think we should be importing humanoids, just throwing it out there, because every time we do that, you bring soldiers into your own country. I think every country should be building your own. And then for that, there's no world standard for you to build your own. It would be really nice if we had open source standards with standards actuators with the best we can, and each country can develop your own version of it. There's no such a thing.
And I want to give one more quick perspective on bottlenecks. I would say funding vehicles is a big one, especially when it comes to being nimble for getting space to the warfighter, for example, or systems to the warfighter, because a typical government contract, it's a dance. It's all these steps and things you have to go through, and it can take a long time, and there's a lot of overhead. The Space Force, for one, has recognized this, and they're looking for ways to shorten that span and make things go to prototype faster and get the brand new technologies out to the warfighter more quickly. But that hasn't caught on to the rest of the services yet, to my knowledge. I think this is something that they're maybe piloting, doing a pilot program for, and I hope they continue to explore this, because there's a lot of great commercial technology, fascinating ideas that are happening today that could really be helpful out there in the field, that just are having a hard time to get there because of those funding vehicles. So that's another bottleneck.